Welcome students. We are back with another lesson. In this lesson, we'll start with new chapter, atoms. So today, we'll start with the topic, Thomson's model of atom. Now back during the beginning of the nuclear physics, people had the idea that your basic element is the atom. Now they had the idea that atom consists of positive as well as negative charge. So it was in the year 1898 when a scientist or your physicist by the name of J.J. Thomson first proposed the atomic model. He proposed that the atom consists of a positively charged sphere. So this orange sphere, can you see? This is positively charged, on which a negative charge particles are embedded on it. Can you see this negative charge particles? Fine. And he called this negatively charged particles as electron. So this is what people used to think how atoms look in the year 1890. Fine. So his model was quite similar to your plum and pudding model. Now can you see this cake? In this cake, can you see this raisins? So according to him, Thomson, this cake is positively charged, in which this raisins, can you see, which are embedded in this cake, they are negatively charged electron. Fine. So this Thomson's model was also known as your plum and pudding model. It was also compared with your watermelon, where can you see this whole red part of the watermelon? This is positively charged, and the seeds which are distributed throughout the watermelon are the negatively charged electron. So we can compare your atomic model to the watermelon as well. So what we have discussed so far, according to Thomson, an atom consists of positively charged sphere with electrons encased in it, or you can also say embedded in it. Now, since the positive and the negative charge are equal in magnitude, an atom is electrically neutral. Now, as you can see in this picture, the magnitude of the negative charge particles, the sum of all these negative charge particles is equal to all of this positive charge particle. So if you have complete positively charged sphere and the sum of this negative charged electrons, then the net result, if you add them, will be 0. And if the total charge or your net charge is 0, in that case this whole atom is neutral. By neutral I mean this atom is stable. So using this Thomson's model, they could have explained various phenomena like your disintegration, your various kind of chemical reactions. But this model was not correct. There were some failures of the Thomson's model. And what were those failures? It could not explain the origin of several spectral lines in the case of hydrogen and other atoms. Fine. Let's skip this spectral lines for now. Okay, we will discuss about the spectral lines in more details in the upcoming classes. For now, let's skip this point number 1. You can go to point number 2. It failed to explain the large angle scattering of alpha particles in Rutherford experiment. So after this failure of this Thomson's model, Rutherford along with his 2 PhD students, Hans Geiger and Ernest Marsden, they worked on the model of the atom using an experiment known as alpha scattering experiment. Here in this picture you can see Rutherford along with his PhD scholar Hans Geiger. Okay, they are working on the alpha particle scattering experiment. Now this alpha particle scattering experiment we'll discuss in our next class. For now we'll discuss what are your alpha particles. So consider helium atom. This is your helium atom. This is the nucleus of the helium atom. Inside the nucleus of the helium atom you have two positively charged particles. These positively charged particles are known as your protons, and two zero charge particles known as your neutrons. So inside the nucleus of the helium atom you have four particles. Out of these four particles, the two particles which are positively charged are your protons, and the two neutral charged. Okay, neutral I means the charge is how much? 0. So two neutral particles which are known as your neutrons. So this is the nucleus of the helium atom. Fine. And around this nucleus you have electrons revolving. Fine. Now since, look, how many positive charges are there? Two positive charge. In order to balance this atom, there should be two negatively charged particles. This negatively charged particle are known as your electrons, which are continuously revolving around this nucleus. Fine. So this is your helium atom. Now let us supply some energy to this helium atom in order to strike off this electron from its electron orbit. Fine. So what happens if you supply energy? This electron will be removed from its orbit. Similarly, this electron will be removed from its orbit. So you have supplied some energy to remove the electron from their orbits. Now what you are left with? You are left with only two protons and two neutrons. Fine. I can also say now let us assume that the mass of this neutron is very similar to the mass of the proton. Fine. This is the mass. If this is a proton, this proton has mass. This is a proton of mass mp, and this is the neutron of mass mn. Now the mass of the proton and mass of the neutron are very similar. Okay, they are quite close to each other. So what you can assume that the mass of the neutron is also how much? mp. So you are left with the nucleus only. Nucleus of mass of how much? Here look, mp plus mp plus mp plus mp. How much? 4 mp. Fine. And now look at the charge of the nucleus. Does your neutron has any charge? No. Only proton has a charge. And what is the charge? The charge is plus E. Okay. If the electron charge is minus E, the proton is opposite of electron. Then how much is the charge? Plus E. So what will be the charge of the nucleus? It is plus E and plus E. That means plus twice of E. So you are left with the nucleus of a helium atom with mass 4 mp and charge plus 2e. So this is your alpha particle. So alpha particle is nothing but a helium ion. What is a helium ion? A helium atom from which both the electrons have been removed. Fine. So that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I will re-explain it to you again. So again, thank you.